Ustedes ya saben qué es lo que tienen que hacer en este momento. Conservar la calma y evacuar de inmediato. Me voy a levantar y voy a evacuar.
On the 19th of September 2017, Mexico was struck by an earthquake with a magnitude of 7.1 and left 370 people dead and 6,000 people injured. The ground shaking that we attribute to earthquakes is a result of built-up friction energy being released from between moving tectonic plates. Mexico is located near three major tectonic plate boundaries, meaning that earthquakes are almost inevitable. The deaths caused by earthquakes aren't the result of the ground shaking itself, but poor building practices. Civil engineers can therefore help reduce these impacts by designing infrastructure that can withstand impacts of earthquakes. In our first workshop, the team built a structure that we placed on a shake table with varying frequencies to model the Mexican earthquake in 2017. The building materials were sticks, straws, sellotape, blue tack, and paper. To our delight, it withstood the lateral forces while being loaded with Mr. Egg on the top. During the workshop, we found that assembly took more time than we anticipated, teaching us that time management is a critical skill for civil engineers. In the second workshop, we investigated how different accelerations would change the angle and shape of a slope composed of a granular soil. We did this by shaping a mound of sand, which had been collected in Mexico, in a plastic container into a slope. We then recorded the dimensions of the slope and placed the lid on the container. After giving it a firm push, the acceleration of the container was measured using a mobile app. We then recorded the new dimensions of the slope and documented all the changes that occurred. The test was repeated 6 times, varying the mass of sand used and the force of the push we gave the container. This activity gave us a clearer understanding of how granular soils may react in response to the ground shaking caused by earthquakes. In our third workshop, we composed an evacuation plan for the Azteca Stadium in Mexico that has a capacity of almost 80,000. Our task was to be able to evacuate the building within 8 minutes. We divided the seats in the stadium into small sections and designed clear labels to indicate directions to the nearest exit and safe place. We also approximated the evacuation time, taking into account the average flow of a crowd. Evacuation plans are vital for earthquake-prone areas as they allow people to escape buildings before the structural elements fail, preventing unnecessary deaths. Overall, in Challenge 1, we learnt that earthquake engineering is a combination of structural, geotechnical, and transportation engineering. It taught us that an integrated approach is the most effective in problem solving within an engineering context.